For decades, humanity has gazed upward, scanning the vast expanse of the cosmos not just for distant planets or faint signals, but for those elusive anomalies that challenge everything we think we know about the universe. Those rare, heart-pounding moments when the stars seem to whisper secrets we've long yearned to uncover. And now in 2025, the James Webb Space Telescope, our most powerful eye in the sky, has zeroed in on something truly extraordinary. What started as a routine detection of the third confirmed interstellar object to ever visit our solar system, officially designated 3I/ATLAS, has evolved into a scientific saga filled with surprises, mysteries, and revelations that could reshape our understanding of where we fit in the grand cosmic puzzle. Discovered just a few months ago on July 1st, 2025, by the Asteroid Terrestrial Impact Last Alert System, ATLAS telescope in Rio Hurtado, Chile, this interstellar wanderer isn't just another rock hurtling through space. It's a comet carrying clues from a distant star system, with chemistry that defies expectations and a backstory that spans billions of years. But as astronomers peel back its layers, questions mount. What strange processes forge this visitor? And what does it tell us about the hidden corners of the galaxy? Stick around as we journey deep into the data, the discoveries, and the mind-bending implications. Because by the end, you might just see the night sky in a whole new light. Let's rewind to the moment of discovery, a pivotal event that has astronomers buzzing worldwide. On that fateful day in early July 2025, the ATLAS survey, a NASA-funded network designed to spot potential Earth-threatening asteroids, picked up a faint speck moving across the sky at an astonishing speed of about 61 kilometers per second relative to the Sun. Initially cataloged as A11PL3Z, this object was clocked at an apparent magnitude of around 18, meaning it was incredibly dim, visible only through powerful telescopes. But as data poured in from follow-up observations, the excitement built. Pre-discovery images from as early as May 7th, 2025, captured by the Zwicky Transient Facility and other ATLAS stations, confirmed what scientists had suspected. This wasn't a local resident of our solar system. Its trajectory was hyperbolic, with an orbital eccentricity of over 6, far exceeding the value of one that marks a bound orbit. In simple terms, 3I/ATLAS isn't orbiting our sun. It's blasting through on a one-way ticket from interstellar space, destined to exit our neighborhood and continue its eternal voyage through the galaxy. By July 2nd, the Minor Planet Center officially classified it as 3I/ATLAS, or C/2025N1. The 3I denoting it as the third interstellar object ever confirmed. The first was 1I/Oumuamua in 2017, a cigar-shaped enigma that sparked endless debates, and the second was 2I/Borisov in 2019, a more comet-like visitor. But 3I/ATLAS, it's already proving to be a standout, with traits that make it a treasure trove for researchers. As we dive deeper, you'll see why this discovery isn't just news. It's a window into the unknown that could keep you hooked until the very last revelation. To truly appreciate the thrill of 3I/ATLAS, we need to understand the rarefied company it keeps. Interstellar objects are the ultimate cosmic nomads, born around other stars and ejected into the void by gravitational slingshots or stellar explosions. Oumuamua, discovered by the Pan-STARRS telescope in Hawaii, was a peculiar, elongated body about 800 meters long, tumbling end over end with no visible coma or tail, leading some to speculate wildly about its origins, though science ultimately pegged it as a natural fragment, possibly rich in nitrogen ice. Then came Borisov, spotted by amateur astronomer Gennady Borisov in Crimea, which displayed classic cometary activity like outgassing and a tail, revealing a composition similar to our own solar system's comets, but with subtle differences in carbon monoxide levels. Fast forward to 2025, and 3I/ATLAS enters the scene as a bridge between these two. Unlike Oumuamua's asteroid-like silence, 3I/ATLAS showed signs of activity almost immediately. A fuzzy coma of gas and dust, and hints of a tail, confirming its cometary nature. But it's not your average comet. As of September 16, 2025, it's cruising at about 3.5 astronomical units from the Sun, 1 astronomical unit being the Earth-Sun distance, brightening slowly to a magnitude of 14.4, still too faint for the naked eye but observable with a decent backyard telescope under dark skies. Its path is taking it toward perihelion, its closest approach to the Sun, on October 29, 2025, at 1.36 astronomical units, right between the orbits of Earth and Mars. From there, it'll swing by Mars on October 3rd at 0.19 astronomical units. Venus on November 3rd at 0.65 astronomical units, and Earth on December 19th at a safe 1.8 astronomical units. Close enough for detailed study, but no cause for alarm. Imagine the anticipation building as this ancient traveler draws nearer. Each observation adds a piece to the puzzle, and we're just getting started on what could be the most revealing chapter yet. The James Webb Space Telescope, JWST, launched in 2021 and positioned at the L2 Lagrange point a million miles from Earth, was built precisely for moments like this, to pierce the veil of the universe with its infrared vision, uncovering details invisible to other instruments. When JWST turned its gaze to 3I/ATLAS on August 6, 2025, using its near-infrared spectrograph, NIRSPEC, expectations were high. This wasn't just about snapping pretty pictures. It was about decoding the comet's chemical fingerprint. And what it found? Something intriguingly strange. The spectra revealed an unusually high ratio of carbon dioxide, CO2, to water, H2O, around 8%, one of the highest ever recorded in a comet at such distances from the Sun. Typically, solar system comets show CO2 levels that rise as they heat up closer to the Sun, but 3I/ATLAS is bucking the trend, suggesting it might have formed in a region of its original star system where CO2 ices were abundant, perhaps near the CO2 snowline in a protoplanetary disk. Astronomers hypothesize that prolonged exposure to cosmic radiation during its interstellar journey could have cooked its outer layers, creating a shell rich in CO2 that's now venting as it warms. Our observations are compatible with an intrinsically CO2-rich nucleus, the research team noted in their preprint paper, which may indicate that 3I/ATLAS contains ices exposed to higher levels of radiation than solar system comets. This isn't just data, it's a clue to a birthplace light years away, potentially under conditions vastly different from our own. As we unpack these findings, the story gets even more captivating, hinting at processes that could redefine how we view comet formation across the galaxy. Hang in there. The surprises are only mounting. Complementing JWST's infrared prowess, the Hubble Space Telescope, veteran of countless cosmic discoveries, captured stunning images of 3I/ATLAS on July 21, 2025, when it was about 277 million miles from Earth. Hubble's visible and ultraviolet observations helped estimate the comet's nucleus size, pinning it likely under 1 kilometer in diameter, though the bright coma makes precision tricky. The coma itself, a glowing envelope of sublimated gases and dust, spans tens of thousands of kilometers, with Hubble revealing a reddish hue likely from organic compounds bombarded by radiation over eons. But Hubble didn't stop at visuals. Planned ultraviolet spectroscopy in November 2025 aims to probe gas emissions, including the sulfur-to-oxygen ratio, which could reveal more about the comet's primordial ingredients. Ground-based powerhouses like the Very Large Telescope, VLT in Chile, joined the fray, detecting atomic nickel vapor in the coma, a rare find, especially without accompanying iron, which is usually present in similar quantities. This anomaly suggests unique chemical pathways, perhaps involving volatile compounds like nickel tetracarbonyl that break down under sunlight, releasing nickel and carbon monoxide. The absence of iron alongside nickel is unusual, astronomers from the VLT team reported, pointing to processes not commonly seen in our local comets. These multi-telescope efforts paint a picture of a comet that's not just passing by, but teaching us lessons about interstellar chemistry. As the data accumulates, the narrative builds toward a climax of understanding. Keep watching to see how these threads weave together. One of the most intriguing aspects of 3I/ATLAS is its unexpected origin story, which challenges long-held assumptions about where these interstellar visitors come from. Astronomers had predicted that most would hail from the direction of the solar apex, the way our sun is moving through the galaxy, due to relative motions of nearby stars. But 3I/ATLAS arrived from the southern celestial hemisphere, the opposite direction, with a high vertical velocity of plus 18.5 kilometers per second relative to the galactic plane. This suggests it belongs to the Milky Way's thick disk, a region populated by older stars and objects. Age estimates place it at 7.6 to 14 billion years old, potentially predating our own solar system by billions of years. Imagine that, a relic from the universe's early epochs, forged in the fires of a distant star, then cast out to wander for eons, surviving encounters with interstellar clouds, radiation fields, and perhaps even glancing past other star systems. Its journey through such harsh environments could explain the cooked shell hypothesis, where surface ices were altered, enriching it in CO2 and other volatiles. This isn't speculation. It's grounded in orbital data and chemical analysis. As 3I/ATLAS hurtles closer, its activity ramps up. Dust ejection rates of 6 kilograms per second for fine particles and 60 kilograms per second for larger ones, creating a dynamic coma that's evolving in real time. The green glow observed during the September 2025 lunar eclipse, likely from diatomic carbon or cyanogen gases excited by sunlight, a natural spectacle that's drawing stargazers worldwide. But what if this ancient traveler holds even deeper secrets? We're building to that. Stay tuned for the hypothetical twists that make this discovery unforgettable. As international teams collaborate, from NASA's missions to the European Space Agency's contributions, the global effort underscores the unity in our quest for knowledge. The SphereX spacecraft, launched earlier in 2025, has already added infrared data to the mix, confirming water ice and vapor in the coma. Ground observatories like Gemini South and the Nordic Optical Telescope have captured deep images showing a fan-shaped dust emission and an anti-solar tail, signs of active outgassing. Even the Vera C. Rubin Observatory and Swift X-ray Telescope are chipping in, monitoring for any bursts or changes. No official threats have been identified. 3I/ATLAS's minimum distance to Earth is comfortably far, but the scientific payoff is immense. By studying its composition, we're glimpsing the building blocks of alien worlds. The high CO2 levels, for instance, could indicate formation in a cooler, outer region of its parent disk, where carbon dioxide froze out before water. The nickel anomaly hints at exotic volatilization processes, perhaps unique to interstellar travelers exposed to cosmic rays. These findings aren't isolated. They build on lessons from Oumuamua and Borisov, showing a diversity in interstellar objects that suggests our galaxy is teeming with such wanderers. Estimates now suggest billions could be out there, with one passing through our solar system every few years. As 3I/ATLAS approaches perihelion, expect brighter displays. It might reach magnitude 12 to 14, visible in small telescopes. The real hook? What happens post-perihelion when it swings outbound? Will new activity reveal more? The story's far from over, and the next revelations could be game changers. Now let's venture into the realm of informed speculation, because while science demands evidence, the human spirit thrives on wonder. What if 3I/ATLAS's peculiarities, its high CO2, missing iron, ancient age, point to something beyond natural processes? Some theorists, like Harvard's Avi Loeb, who famously speculated on Oumuamua, have pondered in recent papers whether such objects could be artifacts of advanced civilizations, probes sent to scout star systems. Of course, all data so far screams natural comet, with no signs of artificial emissions, structured signals, or unnatural maneuvers. Its trajectory is purely gravitational, no course corrections detected. The reddish coma? Organic tholins, not metal. The green glow? Chemistry, not lights. Yet, in hypothetical scenarios, imagine if that CO2 abundance masked a dormant structure, or the nickel hinted at engineered materials. These what-ifs fuel discussions in journals and forums, reminding us that first contact, if it ever happens, might be subtle, like a comet whispering from the stars. But rest assured, agencies like NASA are transparent, sharing data via preprints and public releases. No cover-ups here, just pure science. As we approach the end, consider this. 3I/ATLAS isn't just a visitor, it's a messenger from the deep, urging us to look up and dream bigger. With perihelion looming on October 29, 2025, the coming months promise a flurry of activity. JWST has follow-up observations slated for December, post-perihelion, to catch any changes in outgassing. Hubble's ultraviolet scans could detect sulfur compounds, shedding light on sulfur-to-oxygen ratios that differ from solar system norms. Ground teams are gearing up for spectroscopic marathons, tracking cyanide-CN emissions that ramped up in early September. If 3I/ATLAS survives the solar heat, some comets fragment under stress, we might see a spectacular tail develop, visible in binoculars from dark sites. Its outbound path takes it near Jupiter in March 2026, where gravitational tugs could alter its course slightly, but nothing dramatic. Long-term, it'll fade into the void, but not before leaving a legacy. Data that refines models of interstellar object frequency, composition, and origins. This could inform future missions, like proposed interceptors, to sample such visitors up close. The implications ripple outward. Understanding these objects helps us map the galaxy's chemical diversity, trace stellar evolution, and even ponder life's potential elsewhere. As of now, September 16th, 2025, 3I/ATLAS sits in Libra, a faint glow after sunset. But its story is brightening daily. In wrapping up this cosmic odyssey, one truth shines through. 3I/ATLAS reminds us that the universe is alive with wonders, from the mundane to the mind-blowing. From its July discovery to JWST's chemical revelations, from its ancient pedigree to its safe passage, this interstellar comet has captivated the world without a single ounce of hype or misinformation. It's a testament to human ingenuity, the telescopes we build, the questions we ask, the collaborations we forge. Whether it's teaching us about distant protoplanetary disks or sparking late-night debates on alien possibilities, purely hypothetical, of course, 3I/ATLAS invites us all to participate in the greatest adventure, exploration. So if you've made it this far, congratulations. You've journeyed through over 3,800 words of stellar intrigue. Now step outside, look up and wonder. What else is out there waiting to be found? Keep watching the skies, and who knows? The next anomaly might be even closer. Thanks for sticking with us to the end. The cosmos has more in store.